A car moving at a speed of 36 km per hour is taking a turn on a circular road of radius 50 meters. A small wooden plate is kept on the seat with its plane perpendicular to the radius of the circular road. A small block of mass 100 grams is kept on the seat, which rests against the plate. The friction coefficient between the block and the plate is mu equal to 0.58. Find the normal contact force exerted by the plate on the block. The plate is slowly turned so that the angle between the normal to the plate and the radius of the road slowly increases. Find the angle at which the block will just start sliding on the table. Sorry, on the plate. So let's see the situation. Here, this is block and this is plate. Here also, this is block, this is plate, and here radius is R. So in our question, radius is given as 50 meter. Mass of plate is given as 0.1 kg. And the friction coefficient mu is given as 0.58. So case number 8, we are going to discuss. Here, there will be normal reaction. In this direction, there will be centripetal force, which is equal to centrifugal force. This is centrifugal force, which is outward, and normal will be in this direction. So we can say N equal to mv square upon R. We can put the values. M is 0.1, velocity 36 into 5 by 18. That would be 10 meter per second. So 10 square divided by 50. So this would be equal to 10 divided by 50, which is 0.2 Newton. Now, second case, when plate is slowly turned so that the angle between the normal to the plate and the radius of the road slowly increases. So consider the situation of the plate. Plate is this time like this, and block is here. Now again we consider normal, and this force mv square upon r remains in the same direction. This is perpendicular line. So here mv square upon r will act like this. And now plate, this is plate, this is block. The plate makes angle theta with vertical. So this angle will be 90 minus theta. Then this angle will also be theta. So component of mv square upon r in this direction will be mv square upon r cos theta. And along the plate, its component will be mv square upon r sine theta. So we can take in this direction also mv square upon r sine theta. So since this angle is theta, so we can write mv square upon r sine theta here. And in this direction, we can write friction. So although both will be equal, so in this case, normal reaction will be N dash. So N dash equal to mv square upon r cos theta. And friction will be equal to mv square upon r sine theta. Friction equal to mv square upon r sine theta. But friction is also equal to mu n dash. So mv square upon r sine theta equal to mu times mv square upon r cos theta. Mv square upon r will cancel out, mu equal to tan theta. So let's write it here. So mu equal to sine theta upon cos theta, that is tan theta, and mu is given as 0.58. So theta equal to tan inverse 0.58. And if we evaluate it by using calculator, we will get 30 degrees. So this angle is 30 degrees from vertical. Now consider next question. So next question is, a table with a smooth horizontal surface is placed in a cabin which moves in a circle of large radius, or a smooth pulley of small radius is fastened to the table. Two masses M and 2M placed on the table are connected through a string going over the pulley. Initially, the masses are held by a person with the strings along the outward radius, and then the system is released from this. Find the magnitude of the initial acceleration of the masses as seen from the cabin and the tension in the string. So here, when this system is rotated with angular velocity omega, then force on these masses will be centrifugal force. That is, we assume that radius up to here is r. So if this mass is 2m, so this is 2m times mr omega square. So this will be force on this. And suppose this mass is m, so this force will be m r omega square. So due to these forces, there will be tension in the string, and the two masses will accelerate. So let's analyze it in this way. Now we draw the pulley here, and we keep one mass here. One mass, suppose this is 2m, and this is m. Here, you don't have to consider the effect of gravity, because this situation I have turned like this. So as I told you, the force on 2m is 2mr omega square, and force on this will be mr omega square. Now suppose tension is stay here, tension is stay here. Now, since this mass is bigger, so, and this force will also be bigger than this, so this will move with acceleration a in this direction, and this will move with acceleration a in this direction. So we can apply the formula. So equation of motion normal, or we can say Newton's law. So here net force will be 2m r omega square minus tension is equal to 2ma for this object is 2m object. And now for object of mass m, we can, this equation number 1. And for this, since this mass is going upward, so tension will be larger, T minus mr omega square must be equal to ma. Now, if we add the two equations, so T will cancel out. So we will be left with mr omega square equal to 3ma. Mm will cancel out. We will get A equal to r omega square upon 3. So we have got the acceleration of the two blocks. Now, this acceleration we can put here to get tension. So T equal to mr omega square plus ma. So mr omega square plus m times A. A is r omega square by 3. R omega square by 3. So here, if we take LCM, so 3mr square, 3mr omega square plus mr omega square. So that will be 4 by 3 mr omega square. And that is our answer. Thank you for watching.